complete this experiment, we're going to need an analog ammeter, a strong magnet, 2 leads, and a coil of wire. Rather than make my own, in this case I've chosen to use a pre-made coil, but inside the plastic packaging is a coil of wire coiled right round here, and we're going to plug it in like this. Connect them together using the outside. Connect to the ammeter like so. The ammeter measures the current that flows in the circuit through the leads, through the coil. I want to see how a magnet can be used to induce a current in this circuit. So there's a series of questions I want you to answer using this equipment. Firstly, what happens to the ammeter, to the current that's flowing, if I move the magnet into the coil? Deliberately can't let you see what happens. I want to know if it's different whether we keep the magnet still and move the coil, or just move the magnet. What happens if we just leave the magnet stationary inside the coil? How does the speed that you move the magnet and the coil affect the current? How does the number of coils affect the current? Now, if you have a coil like this one, you can move the lead into the middle and that will reduce the number of coils. So now we have 60 instead of 60 plus 60, which would be 120. If you don't have 3 holes for the leads to go into, you'll have to swap your coil with another group. I'm sure they will be accommodating. Move the magnet in and see what the difference is this time. Lastly, I have some extremely strong neodymium magnets, and I'll come round and we can see how the strength of the magnet affects the current that's induced in the coil. Final 2 questions. How does changing the direction of the motion, in and out, or using the other side of the coil, in and out, or using the opposite end of the magnet, I handily got a dot on one side and not on the other, how does that affect the current that's induced through the coil? So you've got a lot to investigate with your magnet, coil, leads and ammeter. How do we use a magnet to get a current? How does the strength of the magnet, the number of coils, the speed of the movement and the direction of the movement affect the current that's induced?